Hey everyone, it's Maldonado here again. So we're now on week 3 of remote learning. So, hopefully everyone's doing well. Hopefully you guys are taking care of yourselves. So let's go ahead and start this next section. It hurts me to have to do this, remotely because this is almost my favorite chapter. But, it is what it is. We're just going to have to do what we have to do. All right. Okay, so we're going to work with these sum and difference formulas. All right, and these are the 6 that are kind of provided. Now, for extra credit, if anyone wants to prove these two using the sines and cosines from here, I will give that to you. All right, if you can show a way to do it using the sines and cosines on the left, then I will allow you to get that extra credit, right? So to prove these for extra credit if you like. If you don't, it's okay, all right? Just send that to me as an email. All right, so we're going to look at these sum and difference formulas, how they are quite the same yet different. So this is, what is this useful for? All right, so the idea is we know, okay, a lot about these angles here, right? We know a lot about 30, 40, 60, and all the reference angle that deals with those. We know about 90, we know about 180, 270, 0, right? We know a lot about those angles, right? But what if we wanted to figure out 75? Or what if we wanted to figure out like 105 or something like that? Right? How can we come up with these angles giving us an exact value instead of relying on a calculator, right? Because calculator doesn't necessarily give us the exact value. So what this does for us is this actually helps us break some of these angles down so we can represent them in terms of the angles that we truly know and love, right? So in the first one, we have sine of u plus v. All right, so the idea with sines, and if you kind of look at both sines here, they both involve a sine and cosine in the first term. They use the same sign as what's provided. And then again, a sine and cosine in the second one, right? So again, it doesn't matter which way you write it, sine first, cosine first, whatever your case is there, it's the same. But the idea is you're going to take the sine of the first part of the sum times the cosine of the second part of the sum plus the cosine of the first part of the sum times the sine of the second part. All right, same thing with the sine. Sines are the same. The difference with cosines is all cosines come first, sines come later, and then it's actually the opposite sign. So we have plus, we use minus. If we have minus, we use plus. All right, so that's just important for you guys to kind of understand. Same thing with tangent. Tangent in the numerator, it's addition because that's addition, and in the numerator, it's subtraction, and then the denominators are vice versa. All right, so we're going to be using these, as we go on. We don't have too many examples here. A lot of them are kind of left for you guys for homework, but we're going to cover all of these as best as we can. Again, get these into your notebooks because these are going to be ones you're going to be able to use, when you test. And no one really expects you to memorize these, but they're definitely useful to manipulate expressions later on. Okay, here, find the exact value of cosine of 75 degrees. All right, so we're talking about 75 degrees. It's in degree version, right? So cosine of 75. The question is, we only like these angles here. 45, the 0, whatever. So is there any way I can make 75 with one of these two here? All right, now we can make 75 using 30 plus 45. That's going to give us the 75. Now notice that this is just a cosine u plus v, which is going to give me the cosine of the first times the cosine of the second minus the sine of the first, the sine of the second, sine of the first, sine of the second. Using these are going to be a little complex with this, stylus. All right, so that's going to give me the cosine of the first angle, which is 30, times the cosine of the second angle, which is 45, minus the sine of the first angle, which is 30, times the sine of the second angle, which is 45. Okay, so then we just plug in the values that we know. So what is the cosine of 30? Well, that's going to be radical 3 over 2. what is the cosine of 45? Radical 2 over 2. Minus the sine of 30, 1/2, times the sine of 45, radical 2 over 2. So really quickly, that's going to give me radical 6 over 4 minus radical 2 over 4. So we like to write this usually as radical 6 minus radical 2 over the single denominator of 4. That's your exact value of the cosine of 75, all right? So that's how we get it. That's how we're doing it, right? So again, convert this angle into two other angles, either addition or subtraction. It could be one of the two, okay? But find a way to create that, okay? And then once you have that, then it's just a matter of substituting like we did here, okay? And then plugging in the function values that go with that and simplifying, right? Really quick. So again, the first part is just the main part. It's just understanding what the identity is, what's the formula. Once you get it, boom, move on, and it's kind of straightforward from there. All right, here, radians, okay? So now radians, right, we know that 30 is pi over 6, 45 is pi over 4, all right, and pi over 3 is 60. So again, we're just trying to figure out a way for us to get this pi over 12. Now with fractions, okay, it is definitely a little bit more difficult, but here notice that pi over 12 is the same thing as pi over 3 minus pi over 4. That gives me 4 pi over 12 minus 3 pi over 12, and notice that gives you pi over 12. So we're going to want to use the difference of pi over 3 and pi over 4. All right, so we're using sine, so sine of pi over 3 minus pi over 4. So that's going to give me, so we're working with sine here, so it's going to be sine of the first times cosine of the second minus cosine of the first times the sine of the second. Okay, so sine of pi over 3 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Minus cosine of pi over 3 is 1/2, and then we get radical 2 over 2. So this is going to give me radical 6 over 4 minus radical 2 over 4, which gives me radical 6 minus radical 2 over 4. And there's your function value. Okay, so now, again, they're not always, they are going to look very similar, like your answers are going to start to look like they repeat, especially with the sines and cosines. But it's just a matter of a sign changing here or there. But it's pretty much how you're going to work it out, okay? So that's how it looks. Okay. All right, here we're going to find the exact value of sine 42 cosine 12 minus cosine 42 of sine 12. All right, so now you have to identify which of the identities this follows. Since we have a sine and cosine in each of those, I know it's definitely going to be sine. Now is it going to be u plus v or u minus v? So it's definitely going to be u minus v. So in this case, what is u? U is going to be 42. V is 12. 42 minus 12 gives me 30. The sine of 30 gives me 1/2. Okay, so the exact value of this equation here, or this, expression is 1/2. So that's how we can kind of use it in reverse. Okay, here, we're going to write cosine of arctan, of the quantity of arctan 1 plus arc cosine x as an algebraic expression. All right, so what we're going to have to do here really quickly is just do the arctan of 1. So let's quickly draw a right triangle, okay? The arctan of 1, we're saying that the tangent of the angle is 1. So that means that this opposite adjacent is 1, so this gives me radical 2. And then the arc cosine, right? So if this is our angle, is x. So the arc cosine is adjacent over hypotenuse, so x over 1. So we need to find an expression here. So this is going to be the square root of 1 minus x squared when we do Pythagorean theorem. All right, so now it says just to write this as an algebraic expression. Okay, so we're going to use the cosine of u plus v. So that's the cosine of arctan 1 times the cosine of arc cosine x minus the sine of arctan 1 times, I'm running out of space here, sorry, sine of arc cosine x. Okay, so what is the cosine of arctangent of 1? So what's the cosine for this triangle here? The cosine is going to be 1 over radical 2, which is just radical 2 over radical 2 over 2, times the cosine of arc cosine x. So the cosine of arc cosine x is just going to be x, right? Because cosine and arc cosine cancel. Minus, here we have a sine of arctangent of 1. So what's the sine here? The sine is radical 2 over 2. Times the sine or cosine here. So here, what is sine? Sine is going to be radical 1 minus x squared over 1. Okay? So when we multiply this, or we add it together, we get radical 2x minus, we can actually multiply this, so that's going to give us 2 minus 2x squared over 2. Okay, and then there you go, there's your expression. Okay, so again, creating these triangles on the side are going to help you when we start doing the, the inverse functions. All right, so here, prove the cofunction identity cosine of pi over 2 minus x is equal to sine of x. So this is just verifying, so we just need to do a proof. Okay, so this is a cosine of u minus v, so cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. Okay, so cosine of pi over 2, that's 0. 0 times the cosine of x plus 1 times the sine of x. 0 times cosine x is 0. So I'm just going to be left with sine of x, and there you go, there's your proof. All right, so not too bad of a proof, nothing like you've been doing in the previous sections. But there you go, nice and simple, just using the formula to prove the identity. Okay, all right, here simplify each expression. Okay, all right, so here we have cosine of theta minus 3 pi over 2, so it's difference, so we're going to do cosine of a u minus v. So we have the cosine of theta times the cosine of 3 pi over 2 plus the sine of theta times the sine of 3 pi over 2. Okay, now understanding which one of these is going to be equal to 0 is going to be very important, right? The cosine of 3 pi over 2 is 0, so this goes away. This is 0 plus sine theta times negative 1, so we're going to get negative sine theta as our answer for A. For B, now this is our first tangent one, so understanding the tangent identity is important. Okay, so again, we have it listed in the first slide of our presentation here. So this is going to be the tangent of theta plus the tangent of 3 pi over 1 minus the tangent of theta tangent of 3 pi. All right, so we just need to kind of go ahead and figure out what this is going to be equal to us for here. Okay, so we have tangent theta, okay, plus, now tangent of 3 pi. 3 pi lies outside of, I guess, the unit circle, but again, just find the coterminal, so that's going to be 0 of 1 minus 0. So you're going to get tangent theta over 1, and that's going to be tangent theta. All right, so there's your final answer. So it's just using the identities that, or the formulas that we were given to help simplify expressions. Okay, not too bad once you have the formulas in front of you. All right, here's an equation. Find all solutions of this here in this interval. So you need to first combine this into a single sign. Okay, so to do that we use, or actually not into a single sign, we actually have to break down both of these. All right, so what we're going to do here is you're going to have, for the first one here, it's going to be the sine of x cosine of pi over 4 minus the sine of pi over 4 cosine x plus Now the second one, we have sine of x cosine of pi over 4 minus the sine of pi over 4 cosine of x. This should be a sum here, sorry. And that's going to be equal to -1. Okay, so now looking at your like terms here, what do they share in common? So we have sine x cosine pi over 4, sine x cosine x, so that's going to give me 2 sine x cosine pi over 4. Okay, these cancel, so this is equal to -1. Okay, what's the cosine of pi over 4? Well, that's 2 sine x times radical 2 over 2 equals -1. All right, so these two can kind of multiply together here. So that's going to give me radical 2 sine x equals -1. Sine x is equal to -1 over radical 2. Sine x equals negative radical 2 over 2. So where is sine x equal to negative radical 2 over 2 on this particular interval? All right, so that's going to be at the pi over 4 marks, but which pi over 4 marks in particular? It's going to be at the 5 pi over 4 mark and the 7 pi over 4 mark. So those are your two solutions for this one. Okay, so again, just using the formulas to kind of help things out in all different facets. So again, not one that we're asked to be memorized, but one of them that we kind of have to reference and use just in case we need to do it. All right, now here's more of a calc problem. They want to verify that this here is equal to this expression. So notice here that we have sine of x plus h, okay? So what we're going to do is that's going to be sine of x cosine of h plus sine of h cosine of x minus sine of x all over h, okay? All right, so now we need to continue a little bit here, okay? And where can we continue? How? Because again, we want to get to this particular answer here. All right, so well, I notice here that everything in the numerator is divisible by, oh, actually it's not already. What can we do? What can we do? Okay, one thing I can do here is I can regroup this. We have sine of h cosine of x plus sine of x cosine of h minus sine x over h. I just rewrote it so that I can kind of combine like terms here, okay? So I have sine of h cosine x over h plus here I can factor out a sine of x. And that's going to give me cosine of h minus 1 over h. Okay, so we kind of have what we want. We have sine of h over h. We have the cosine of x. Okay, here it's a plus, but we can easily change that by factoring out the -1 here. If I factor out that -1, this becomes negative. Okay, this becomes a sum, and this becomes a negative. So there you go. There's your identity. All right, so that's how you verify that. Sorry for the mess on this one. Kind of ran out of room. Maybe I should have wrote a little bit smaller. But again, that's that. If you need to see the work for this, maybe I can, post that as well a little bit clearer so you guys can kind of see how we got that. But again, it's just using the formula rule to kind of break things down for us. All right, so that's pretty much the gist of the section. Okay, hopefully this video, guys, helps you guys out. Again, any questions, feel free to ask me in Google Classroom. You guys have been doing a very good job of that. So hopefully, this helps you guys out. All right, thanks for watching. And hopefully we get back to the classroom as quickly as we can. All right, have a good day.